Normally I'm just delayed, but let's see where we can take this. Okay, hi, I'm Philipp. I traveled too much. I arrived at 1:30 a.m. in Riga tonight. I have another talk tomorrow morning in Berlin, so sometimes I don't even know where I am today anymore. Anyway, at least I know the tech stuff I talk about. So let's dive into logging and logging patterns a bit. So oftentimes you're running an application, and yeah, my demo here is using Java, but never mind. And you can see it's logging various things, and probably interesting stuff like you have a session information, and you have a loop, and then you have a message, and you have a date and a timestamp, a log level, where stuff is coming from. So you have a lot of good stuff in your logs that you might want to figure out what is even going on in my application. And then at some point something is going wrong in your application, and you start debugging and start to look at your logs. And sometimes you start off with cat logs, whatever log file you have. Who is doing that? Cat, good old cat. Okay. That's okay. Maybe you can use something better. Who is using something like that? Tail F. Yeah, much better. Could there be something better than tail F? Yes, grab. So I like less plus F, plus capital F. Anybody knows what that's doing? That's the same thing as tail F. The only thing is you can break out of that and then keep searching and skipping around in your file. And you don't, because tail F is just really tailing the file, and there is no way to just say, oh, I want to search something in that file now. Then you need to break out of tail F, and then you need to start less or whatever to actually search something. With tail plus capital F, you're automatically tailing the file. But with Q, you can just break out of that, and then you can just, with /, you can start searching. With capital G, you jump to the end of the file, or you can just go up and down. So this is kind of a bit more advanced to search around your log files. However, sometimes everything is on fire, and then you can start tail F or whatever, but it's not going to make you happy. Especially if you have an application that has multiple pieces or is distributed amongst hosts, it's getting to be more painful. So then you start opening multiple windows. So you can see here I'm using cat, whatever. I'm using cat in 3 different windows because let's assume our application has 3 nodes. And then you start looking around for stuff. Is this going to be fun? Yeah, it's some kind of fun. I once saw the tweet where somebody said something like, oh, I like murder mysteries, so I like doing stuff like this. Because you have like little clues here and there, and you just start searching around where is even stuff that I'm interested in. And well, you keep doing that, and then you have more and more windows, and basically now I just see 1 line per log file anymore, because it's just too many things I want to keep track of. And basically where you end up is something like this then. And everything is on fire, everything is terrible, and we don't want to get there. That is basically the idea that we want to avoid, at least this bottom half. By the way, you don't need to raise your hand to say like, I think this is us. Everybody can think that for themselves and say like, yeah, maybe this is us. So who is using SSH and tail F or something like that to debug? Who is doing that and has more than 3 servers? Is it fun? And if anybody says yes now, that's probably the Stockholm Syndrome, where you basically accept that, well, it is bad, I have been taken captive, but I accept my situation and I will do the best with it. The idea is kind of to break out of that loop, and maybe we can do log all the things, but in a slightly better and nicer way. So yeah, like we've said, I work for Elastic. By now, because developer advocate always sounds so preachy, I'm always using this avocado because nobody knows what it means. And then it's this Developerfruit, and I'm a Developerfruit now. That's my official title now, and everybody is fine with that. This is even my email signature. So yeah. So well, we have these nice products: Elasticsearch, Logsearch, Kibana, good old Elk stack. Well, we just took the first letters and one is sitting on top of the other. Is anybody using that for logging already? Yes, my friends. And if anything is not working as well as you want it to be, we can also discuss that afterwards. Because yes, sometimes there are rough edges. I will just try to show you how to make your life a bit nicer and easier. So ELK is kind of the well-known acronym that everybody has known, and well, everybody thinks of the ELK, and we put it out there. Unfortunately, we added another component, or maybe not unfortunately, but ELK is not the full thing anymore. We have added beats now, and beats is like a lightweight agent or shipper. The thing with Logstash is, it's very nice, it's powerful, it started off as Ruby, now it's JRuby, so you always need the JVM. And especially if you're not a Java shop, people were not too happy to add the JVM to stuff. So what we have instead now is we have beats, which is written in Go, so you get native binaries, and it's like a lightweight shipper or forwarder, which is basically just tailing a file. It's pretty much like tail F over the network, but on steroids, basically. That's the general idea of what we have. The problem is there is no B in ELK. And, well, at first we tried to come up with this, where the ELK is kind of morphing into the ELK B or BELK. And you can see, this is the ELK B or BELK. Might also look something like this. And you can see it clearly has its history with the horns, and the B body then is kind of evolving. The problem is, for us, it's always about scaling. And even marketing figured out that this is not scalable, because what happens if we add another product in the future? Then we need to redo the entire marketing. And also we need to come up with another animal. And whatever the next letter is, it's going to be very hard. And we didn't want to take on that challenge. So this was kind of like an internal thing mainly, and we don't really use it that much. We now went the boring route. Basically, we just call it the Elastic Stack. A, to strengthen the company name, and B, because this is very scalable. Whatever open source component we have, we can just put it in there, and it's still the Elastic Stack. That's kind of the general idea. And it looks something like this. If you've never seen that, by the way, we changed the logos at some point. Our Photoshop skills improved over time. So initially, those were kind of crude and funny, or but funny, I don't know. For example, Logstash was a wooden log. And I know a lot of people like that, but again, our marketing team was like, well, we're paid full time to do marketing now, we need proper logos, we want to redo them. So these are kind of like the new rebranded logos, which we did like 2 years ago or so already. So generally the idea is you have Elasticsearch, which is kind of the core where you store all your data. And this started off as full text search. So if you're searching on Wikipedia, GitHub, Stack Overflow, I think if you're ordering an Uber, for example, which doesn't seem to be around in Latvia, but if you would order an Uber, your search is also going through Elasticsearch. This is kind of search. And then we expanded that to other things, because people figured out at some point, if you have logs, storing the logs is the boring part. You want to actually find stuff in your logs. So for us, logs are also a search problem. That's why we kind of expanded the stack. And then we added other open source projects. So all these other open source projects kind of started off independently, and we just brought them in. We always say they joined the family, because their founders probably wouldn't want to hear that they were bought in. So we always say they joined the family. So we have Kibana to visualize stuff, to see what is going on in your stack. We have Logstash, which by now is more like an ETL tool, so it can get data from lots of sources, transform it, enrich it, and then store it somewhere, for example, Elasticsearch. Any ideas what I mean when I say enrich? What could I mean with enrichment? Sorry? Yeah, it's adding fields, that's true. For example, one thing is if you have a log file and you have IP addresses, you might be interested in the GeoIP data or in the geographic data. So basically we do a GeoIP lookup at insert time. We try to reverse engineer where you're coming from or where that IP address is coming from. So we might add the country, the city, and things like that. And then we have beats, which is like the lightweight agent or forwarder or shipper. Okay, that's the stack. So all of that is Apache 2 licensed. You can just use it, and let's dive in and see how you work with your application. So generally, I build highly monitored Hello World applications. Since we have only 30 minutes, I don't think I will demo much today. But there is code for all of this online. I will show you where you can get it and try it out afterwards as well. So the demo I generally have in mind here, but this applies to pretty much everything, is Java, which is boring language, but it kind of works. So I'm looking at using as a logging facade SLF4j. This is basically the thing you interact with in your application. This is where you're telling it, okay, this is the data I want to store. Logback is kind of the thing that writes out my logs. And MDC, anybody here from the Java ecosystem and remembers what MDC is? Map diagnostic context is basically structured information that you want to log. For example, if you have users that log in, you might always want to store that user ID or username with your log events. So if a user comes to you and complains afterwards and says your site is broken, you can say basically, okay, let's pull up your logs and see what you have done and which errors you encountered. So it's basically just structured information that you want to add to your events. And those structured informations make it very easy to kind of slice into your data and figure out what people have been up to, if you add the relevant information. The same would work for pretty much any other programming language. I just took .NET, PHP, JavaScript for no specific reason, but they all have good log appenders, which you can use, and then just go crazy and start logging with them. Okay, first off, before we dive into actually getting the logs, two things probably we don't want to do or we want to avoid. The first one is anybody using print for logging? Okay, you don't have to admit it, it's okay. Okay?
In Kubernetes, everything goes to standard out.
Yes. However, writing to standard out is fine. However, you probably still don't want to use print for that. Because what's the main downside of using print? Yeah, it might. What is the other problem? Sorry? Yes, exactly. You don't have log levels because sometimes you don't want to have all the information and sometimes you do. So generally, if you have system out, it's pretty much a nuclear option. It's just like, okay, whatever is in there, you write out. But for logging, oftentimes, you're only interested in specific things, so you want to tune your log level. And yeah, let's just assume we don't want to use print for logging. The other thing is, what we don't want is any tight coupling between your application. So if I have to use a specific import, for example, every time I'm using a log statement, I would have a very tight coupling, because if I want to replace my logging solution, I would I would have to touch my entire code base and change stuff in my entire code base. And that's something you don't want to do. So basically, where you want your logging to happen or your logging to change is in your log appender. And that's the one place where you want to change the configuration to switch from one system to another. Otherwise, you have very tight coupling, and if you ever switch your log provider, it will be a pain in the ass. Don't do that. Okay, so I want to kind of dive into 5 different patterns or things that you can do with logging. The first one is we parse our log file, which is basically you have the classic good old log file that I've shown in the very beginning, and we want to parse that. Who is doing that? Okay, who likes doing that? Okay, so the general idea is your application is writing out the good old log file, so basically you have the structured information in your application, and then you write it out as a log line, and then you need to parse it back to make sense of it. So what it looks like is you have your classical log file, filebeat basically tails that log file and forwards it to logstash. Logstash is then taking a regular expression to parse the elements apart. Then we store it in Elasticsearch, and Kibana can visualize that. Sounds simple enough, right? The problem is, or let's start with the good part. The good part is, whatever you've been doing before, you can keep doing, because pretty much everybody started off with regular log lines. You can just keep using them. You don't need to change anything in your application. The main downside is, first off, you need to write the regular expression. So if you have that square bracket, then you have the date, then you have the timestamp, then you close the square bracket, then you have the severity, then you have, I don't know, the thread ID, then you have the log message, or whatever you have, whatever that pattern is, you will need to write a regular expression to parse that back. Who enjoys writing regular expressions? That's the Stockholm Syndrome again, right? It's just like you're very used to doing something, and at some point you basically accept your pain. And well, I'm personally lazy. I hate writing regular expressions, and maybe so should you. The next thing is sometimes you have timestamps which are like local time, which always throw me off. And the final thing that is often a pain is, or are multi-line statements. So if you have, for example, Java, and you have the big bag stack trace that is 200 lines long, what happens oftentimes when you consume the log file in a bad way is that you break up the stack trace into lines. So each line is an independent event. Does one line of a stack trace make much sense on its own? No. So how could you work around that then? Basically, the idea is then beats, or file beat here is tailing my log file. Basically, what you will need to do is you will need to tell the beat here what one event is. So basically, you say a new event starts with a square bracket, and then there is timestamp, whatever. If there is not a square bracket, it's kind of the tab or whatever, however your pattern looks like, it's kind of a stack trace, and that is kind of the continuation of the previous square bracket. And you need to add that rule basically when you collect one line and say, okay, this is not just one line that is an event, but this event is basically like 100 lines because our stack trace is 99 lines and the kind of header line with the information of what we've been doing. And you need to add that information. Otherwise, you will break up your stack traces in independent lines, and they are pretty much garbage in your system. You can always check that if you parse your log files, and you know you have written 200 log events, but you have 300 log events in Elasticsearch, then you know that you're breaking up your events the wrong way. Okay, so let's say we want to do something differently. What could we do to make this easier? I don't want to write out my information to a file because, well, my application has it in a structured format, and it's kind of stupid to write it out in a line to parse it back afterwards again. So what could I do to make that process easier? Yes, that's step 3, something else before. But it's a good point, we'll get to that. That's also what we kind of recommend. Send it, yes. The second one is to send it directly. So basically what that looks like is in my log appender, maybe you need another dependency, maybe not, depends on the log appender. Basically in your log appender where you have the data in a structured format, you say don't write this out to disk to a log line, but forward it to logstash. And logstash has the right input to take that information directly and then forward it. And we don't need to do any parsing because it's kind of structured here. And we're just having, if you have the log appender, so log4j or logback, there is an input in logstash which can take the data directly and forward that. So you don't write it out to disk, you forward it in a more or less structured format that the logstash needs to understand. You forward that and take that. And then you don't need to do any parsing. Is anybody doing that? Okay. Downsides? Yeah, performance might. On the other hand, like serializing something to disk has also an overhead. Like, yeah, that's another good point. Who is using TCP for that? Who is using UDP for that? Okay, because I always have the feeling that when you're using UDP, it always works when you don't care, and it doesn't work when you do care. Or maybe that's just like my too negative approach for that. Yes, UDP obviously has the gain that it is more performant because where you don't need to do a 3-way handshake to establish the connection. UDP is nice because it's fire and forget, but it's also the downside that's, well, it's fire and forget. So if your logging system is not there, all your logs go to dev null basically, which is acceptable for some people because, well, it's only logs. Okay, so the pro is basically we don't have a file and we don't need to parse from a file. For me, the main downside is basically if your network, for example, is having a bad day, your application is probably having a bad day and you want to see your logs. The only thing is, if your network is having a bad day and you send your log data over the network, also your log files will have a bad day and you will miss the log events probably. So depending on your log appender, I think with logback the default configuration is to have a buffer of up to 200 megabytes, so it can locally buffer 200 megabytes of data. Once you have reached that limit, it will throw away the oldest events. It also depends a bit on the log appender, like bad ones will open a new thread every now and then if it cannot reach the log system. and fill up the buffer. And I've seen log appenders that took down the production application because they couldn't reach the logging system, which is not really what you want. Like that is a hard requirement you don't want. It does depend. The good log appenders, most of them don't care, they will just throw away the oldest events. Bad ones might take down your production application. I would just test it. So take down the logging receiver, start using your application and see if everything still works as expected. Also you have this tighter coupling between your application and the logging system then, because, well, you're talking directly. Every time you change your logstash configuration or you change servers for your logstash, you need to make that or include that change in your application so it can send the logs to the right place. Maybe some downside for that. Okay, next up, structure, what we already have. This is pretty much the idea, well, I have the information structured in my application or in my log appender. Why not write it out in a structured format to disk? So I don't need to write that stupid regular expression, but can consume it directly. For Elasticsearch, since we're using JSON, writing it out in JSON directly would make most sense. Though you can also use key value pairs, and then we just parse key value pairs because that's also pretty simple normally. And the setup would look something like this. So your log appender just writes out, for example, a JSON file. My beat just tails the JSON file and can store it directly in Elasticsearch because, well, that's doing Elasticsearch, and then you can use it in Kibana. If you have the right log appender, that's also in the demo, that works with MDC and everything else, so you don't have to do any hard work there anymore. The nice thing is, you don't need to do any parsing. It is already in the right format for Elasticsearch at least. JSON serialization just has a bit of an overhead. The other downside is if you need to manually read that file, I personally don't like reading JSON log files that much. So if you need to fall back for whatever reason to reading it on disk, it could be slightly more painful. But it's generally, for centralizing, it's a good approach and will make your life much easier. Okay, next up, everything needs to run in Docker today, right? So yeah, Docker, by the way, I would think that the right logo for Docker is this one. This is also like how large are your containers, something like this normally, right? Anyway, so Docker fixes some awesome stuff like the it works on my machine has been replaced by it works in my container, but you still want to figure out what is going on in your container, so you want to get the logs. So where do you put the beat to forward the log files? You can put it on the host if you want to. Generally, I would not put it in the container with your application because you don't want to couple those together. We would recommend to run it as a sidecar. So basically, you have your application running, and then you have another container running which will collect those log files. And we have decent integration for that. For example, you can basically say, I want to, you're using the default JSON log, which is going somewhere in this weird path, and this star here, this is basically the image ID or the running container ID. And basically we're just tailing any log file being written out by my container, and then we have something to enrich that information as well. So if you add this annotation here, basically we're querying the Docker daemon, and we are enriching that ID information with information from the Docker daemon. So every log event would get additional information with something like this. So we would know, for example, this was the ID, and then we could retrieve labels or the base image or the application name, and you can then filter down on that as well. So you get the additional meta information for that. The alternative is, or the downside is, if you do that, you shut down your container. Maybe it doesn't write out everything to the JSON log anymore. The alternative would be you build your application, you run it, and you mount a specific folder. This folder, this folder here. You mount a specific folder where you write out your log file. So you write out your log file to a bind-mounted directory. This is especially for all the applications that don't write to system out, and they expect to write to this specific file. Then you could just mount that specific file, and FileBeat could then collect that log file. So you're basically mounting that log file into the sidecar and collect it from there. The main downside with this approach is you lose the meta information because, well, for FileBeat, this is just one file you mounted, and it is not really directly related to that container anymore. So you kind of miss some of the meta information in that. One other trick that is, or I would highly recommend, is if you're using containers, we have a so-called registry file. The registry file keeps track basically of where are you in your log file. It's basically a pointer to your log file, and FileBeat knows because of that pointer all the events before we have consumed already or sent, and it will also be acknowledged from the receiving side. And these are all the future events. The thing is, if you have that registry file inside the container, what happens if you upgrade FileBeat? Then you lose that file, and then if you come up, or if you replace it with a newer version, it would have an empty registry file, and then it would start tailing the file basically from the very start again. So what you could do is you could put that registry file on a bind-mounted directory again, and then you keep basically the pointer. So even if you replace the FileBeat, it will keep the pointer to where it was in the log file, and it will not resend the old events, but will know where to continue from the previous version basically. That will avoid you to have duplicate events. One other thing that I see sometimes that is very annoying is that your logs are polluted with something like this, because Redis wants to be cute and they have this ASCII art when you start up Redis, but nobody cares for that in their logs. We have added now something that I find kind of nice. We call it auto-discover. So basically we say, you have a Docker container running, and then you have a condition. And the condition is basically if the container image is or contains Redis. And if it is Redis, then we want to apply a specific rule. And that rule basically says, this is the regular expression, this is the regular expression to exclude these ASCII art lines. So basically you can filter down, you can filter statically. So FileBeat could say, I only care about warn and error messages, and debug and info I want to throw away because I don't want to centralize them. That would be static, but you can also make this dynamic. And this setup is basically dynamic. So if your image is based on Redis, and we are getting that from the meta information from the container again, then you could apply a specific rule, and that specific rule would get rid of that ASCII art. Okay. So the good thing is it's all the hot stuff. The bad thing is what we see, we have official Docker images. Like I think half of the questions or so that we get for our Docker images are for Docker and not our products anymore. Because a lot of people don't really know how to use Docker, which is kind of a common theme. Okay, finally, if you orchestrate, I guess we're just talking about Kubernetes, right? Is anybody using anything else? By the way, when I was talking about Docker, I assumed like for your containers, everybody is using Docker, right? And not something else. Or at least that's what I commonly see. So let's say Kubernetes, because we only have a Kubernetes integration. Where do you put your FileBeat? Generally a daemon set, which will make sure that there is one instance running on your host, and that can then collect all the log files from that host. We do have what we have for the Docker metadata, we also have for Kubernetes metadata. So basically, we can then retrieve like which pod is this running on and other meta information from Kubernetes. We can enrich your events with that as well. And that would then look something like this. So here, for example, you could see we have the namespace, the name, the pod, the labels, the image where this is based on. All of this meta information could be retrieved through the API, and all your events will be enriched with that. So you can filter down and give me just the information for a specific namespace or pod or from one node that is struggling. And again, you can configure your templates here. We're using a namespace for the Redis events, and basically we're using that namespace information then to get rid of that ASCII art that Redis is adding. One thing that I find very useful is if you have multiple namespaces, you might want to have different indices where you log based on a namespace. And we can, in the output where we store the information, you can use that meta information as well to customize the index where this is going. So here, for example, if I have my namespace was Redis in my previous example, that index would be Redis dash whatever FileBeat version you have, which would be 641 today, and then we would have a daily pattern. So you could have one different index per namespace and day, or pod, or whatever makes sense. So whatever you have as meta information, you could put into your index name to split it up if you need that. Yes, it's even hotter and it's even more complex. That's also what we see. Okay, to wrap up, because we are down to 20 seconds, if you want to play around with the code, this is where you can get the code. This is the one thing. basically it even has like the right steps. Let me quickly show you. So here, basically here is the code, and it shows you how to run this. So here, these are just the steps to figure out how stuff is working or not working. Okay. This is what we went through: parse, send, structure, containerize, orchestrate. I don't think I need to repeat them. Any questions? By the way, before you run off, I normally take a picture with you so I can prove to my colleagues that I've been working. No, they don't know where I am, and my boss doesn't really, he says always he doesn't need to know where I am, but I still like to have like some way to prove that I've been working today. Smile everybody, wave, wave, wave. Perfect, thank you. Any questions? And don't forget the stickers afterwards.
So is there one, yep.
Do you have some quick notes on comparisons between Fluentd in a Kubernetes environment versus FileBeat?
Fluentd. I mean, performance comparisons are always very hard. Fluentd is just technology-wise slightly different than Beats, because from what I know, Fluentd is written also in Ruby, right? And I mean, we see a lot of people struggle with Fluentd. That the main thing why people normally use Fluentd is because it's kind of built into the ecosystem and it's part of the Cloud Native Foundation, and it's kind of the default choice. I don't have like specific performance numbers. It's just like our integration for features should be pretty much on par with Fluentd, and generally performance-wise, I don't think it should be worse. It should rather be better, but I don't have like specific numbers. But I honestly have never used Fluentd in production, or even in development. So I have a rough idea of how it works, but I don't have like the experience to say like, okay, this was the overhead and this. But if you suffer from performance issues, maybe you want to try out something else. Cool, if you have any other questions, just come to me. I'm happy to answer. We can also try to debug stuff. I always try to figure out to learn something as well. Thanks so much. Enjoy your coffee break.
Thank you, Philipp.